Now, because we really haven't done any simulation yet, I'm not going to throw us in the deep end of that whole scenario when we're just trying to talk about getting files in and out of Houdini. So really, I'm going to just skip forward here into a version of this project that has all the simulation done for us already. So I'm going to bring in this other Houdini file, like so. And you can see I've done everything already here. I'm going to just save this into that directory. I'm going to actually just save this over the file that we just created. So hit accept, overwrite. Cool. So now I've actually cached out all these RBDs and pyros and all that stuff. So what I need to do is, because my file caches are referencing a cache folder in the same directory, I'm just going to copy that over real quick. I have that in my lesson prep file over here. So I go to lesson files and lesson 6 prep. I've got a cache folder. So I'm just going to drop that in here and everything should work out. So if I go to my RED cache and I go select my camera, it should be playing back my thing. So yeah, it looks like it's actually trying to play back everything. We'll just say hide other objects so we can look at this. So this is the initial sim that I did. Basically what I'd done is I had brought in my geometry like so. I did a fracturing setup and ran a rigid body sim and then imported it. And so the rigid body sim looks like so. You can see if I also bring up my and it's looking for this. I'm going to bring in, change that. So now we're looking at the Alembic file that we brought in before. And I'm just going to hop over here. So now if I play this back, you can see it doing its thing. I actually want to have this highlighted down here. Basically what I did at the end of this project was I took the club and the T and just merged them together and added a normal, because when we merged them together, the club became inside out. Sometimes you got to do that when you're merging things, but basically I just I merged these and give them normal so that when I'm out here I can actually see the golf club in reference along with my simulation. So we have this RBD sim, and if I play it back, we're shattering that golf club now, or that golf ball now. And then also I've done a pyro and a particle simulation. If I just play back this little play blast I made here, this is sort of what the scene is now doing. So I want to export all these elements. I've got smoke, I've got particles, and I've got rigids that I want to take out of Cinema now and take out of Houdini and take into Cinema. So this is what we got, and let's work on getting these things out and back into Cinema. So let's first focus on the RBDs. I'm just going to dive in here. What I've done is I've imported from my sim and then done a RBD cache. So I've got my file cache here. It's playing back nicely, just like so. What I want to do to get this out is to write it out to an Alembic file. So a lot of times what I'll do is right here I just threw down a time shift node so that if I was doing any time remapping or anything like that, or computing velocity, it would be clamped to the start and end frame of this file cache, which is written out from 0 to 72 frames. This just prevents it from trying to read files that are outside of those bounds, like -1 or 73. Can't see them anymore. It's just being locked down. So that's just there for maintenance. And then here I've got my RBD cache. So if I middle mouse click on this, you can see that it's got all these attributes that are coming out of our sim. And the way rigid bodies work is they generally tend to be packed primitives, which is a super efficient way of storing transform data and, running our simulations. Not going to get into too much detail about that right now, but generally what you want to do is you want to unpack the geo to get it back. This is similar to how we were converting our geo when we were importing our Alembic. So if I just throw it on an unpack here, and I wire this in and highlight that, you can see we get our polylines back and stuff like that. Now if I middle mouse click on it, all those attributes have more or less disappeared, and we're left with our name and path, and we've got our UVs back, and we've got some groups here that were created based off of the inside and outside parts of our geometry. So for example, back here, if I zoom in on our geo and I were to split, and I want to split this out by our inside faces. So I'll just grab the inside faces and I'll just throw it on 2 nulls. I'll throw it on a null for the inside faces, and then another null for the outside faces. Let's call this inside. So you can see here that these groups were created by the fracture setup initially, but we can actually send these 2 groups out. They will go out with our Alembic file and come in as face selection sets in Cinema 4D. So good to know that they're there. This split is more or less for demonstration purposes. I just wanted to kind of show the difference between our outside shell of the sphere that we originally had and all the inside geometry that was created when we did our fracture. So there's that. So we've unpacked our geometry, and you can see that it doesn't have any velocity with it. Now I could transfer velocity from this. I could transfer velocity in the unpack by transferring its attribute right here and selecting it from this list. But I find that with rotations and everything, it's just better to recalculate it at this time. So if we wanted to do any motion blur on these objects in Cinema 4D, we would want to have velocity data stored on the individual points of the geometry itself, because then that can be read by the renderer and converted into motion blur. So if I go and do a trail, and I use this trail to compute velocity, and then I turn on my velocity trails here, you can see that it is it's actually computing our velocity, and you can see those trails are trailing in the directions of the geometry. So that's one way to get velocity. You know, if you have a liquid sim, you could transfer your velocity using an attribute transfer as well. I think that because in our situation we have a consistent topology, I don't think it's going to be totally necessary to transfer velocity in this way to recompute it, simply because the point counts aren't changing. Our Alembic file is going to know that this piece had this many points and this many polys, and it's just simply moving through space. It should be able to easily calculate motion blur for us if we need it. But if it doesn't, we can actually store it in an attribute like this. But when it computes velocity, it's actually computing velocity as a point attribute, and Cinema 4D on Alembic files can only really read vertex attributes. So what you'd want to do at this point is promote. So we're going to do an attribute promote. I'm just going to wire this in here, and I got to select my velocity attribute here, and then its original class is point, and the new class is going to be a vertex attribute. So now if I middle mouse click here, you can see we've got normals, UVs, and velocity attributes on our geo. Now you could also put pretty much any other map you'd want on here. You could put a map of color, so you could bring point color in with your Alembics as well. And again, if you had color of any sort on your points, you would just want to do a promote as well, where you're promoting from CD, from point to vertex. So very, very basic, just sort of maintenance, housekeeping types of things that you have to do here. So next, what I want to do is I want to just minimize this file size the best I can. So I'm not going to need the name attribute or the path attribute. In fact, having them will kind of create issues on the cinema side. So I want to blast all this other stuff away. So looks like I've got primitive attributes that I don't need, detail attributes I don't need, and I really don't need all these other groups. I just want to keep inside and outside. So let's just do a group delete. And the first thing I'll do is I'm going to delete all the groups except for inside and outside. So I've got what I can do to delete everything is asterisks. Asterisks, you can see now there are no groups left. Where up here we had all these primitive groups, down here no more groups. So I can use asterisks to delete everything, and then I can use a caret to say basically except the inside group, so inside, and then except also outside. And so now it will actually keep those two groups because we use this little caret in front. And this works in any part of any types of group field things that you have to do in Houdini. So if I middle mouse now, you can see we still have our two prim groups here. You can also do this for attributes, but we're going to throw down an attribute delete. Like so. And I'll wire this in, I'll highlight it, and we've got all our attributes still, but I want to delete all my, I just want to delete the rest attribute. Even if I tried to delete the position attribute, it keeps it because position is just basically needed for any geometry to be represented in any meaningful way. But over here, maybe I don't need to necessarily send my normals over. I haven't done anything specifically or particularly tricky with the normals. If I need them, I can always come back and re-export them. So maybe I'll just say that I want to delete my normals as well. And you can see I've got texture and velocity. I'm going to keep those for now. Maybe because maybe I want to actually do some UVing of the ball's surface. I want to be texturing it, so I need UVs for that. So I'm going to carry over the UVs and the normals. Primitive attributes, don't want any of them. I'm going to throw down an asterisk. Oops, asterisk. And detail attributes, don't want any of them. Just going to throw down another asterisk. So now you can see back up here when we had our trail, we had all this stuff. Now down here, after our attribute delete, it's all been cleaned. We just have positions, UVs, velocity, and inside and outside group. So now the only thing that I would do is keep in mind that we need to scale this up either here or in Cinema to get it back to the original size that it was in its original project. So a lot of times what I'll do just to make things simple is throw down transform and just scale this up by whatever value I scaled it down by. So we brought this down to 1/10 of the size. Let's bring it up to 10. And then I just need an alembic output. So we've got a ROP alembic output, and this is just the output driver. This is just going to take our geometry and write it out to disk just the way we need it to be. So here I want to create a new directory. So you can see I have hip/output ABC. That's just going to put it in the directory next to our Houdini file. So I want to actually put it into another folder named similarly. I'll call this Houdini ABC export. So let's just create that directory. I'll just write that who_abc_export and then put another slash, and then I'll name this something like RBD fracture. And I also like to just put down a little null here. I'll call this capital RBD fracture as well. And so here, now that I've got this RBD fracture name down here, I'm just going to put down $OS so that it names this ABC file. It'll evaluate to our tutorial path who ABC export _RBD fracture.abc. So all good there. By default, it's set to render current frame. I'm going to change that to render frame range 0 to 72. Basically, it's pulling those numbers from our frame start and end, which we set already down here on the left and right. So we're good to go. I'm going to click Save to Disk, and we should get a little bit of a pop-up. It actually, you can see down here, it's going so fast, it's almost done, and it's done. So now, if I go back over here to the Cinema side, and I've got my camera here, everything. So now what I can do is I can actually import this. So I'm going to go up here, File, Merge, and we'll just go back to the Lesson 6 and go to the Houdini ABC export and grab our RBD fracture ABC file that was created for us and hit Open. And it asks you a bunch of questions. Here, basically, I like to make sure I've got color maps and other attributes selected in case I need them. And then everything else is basically good to go. Here, if you didn't do any scaling in Houdini, you do have the option to scale your things up right here. But what I'm going to do is I'm going to just set this back to 1 because we already pre-scaled it in Houdini, and I'll hit OK. And now, if I scrub my timeline, you can see that I've got this fracturing golf ball geometry has been imported in our scene, and it's exactly where it's supposed to be, which is great. So now I can really kind of just turn off this other ball since we're replacing it with our fracture. Hit the play button, and there you go. We're getting fractures. Awesome. Let's look at this import RBD. You can see right here, it looks like it has imported 2 items. Now this can sometimes happen, and it can be a little bit confusing. It looks like maybe there was some form of like a degenerate primitive that it's reading in as a spline right here. If I turn this off, maybe if I magic solo it, it looks like there's a couple stray pieces of geometry that are floating around here. I mean, and at this point, if you were to just delete it, you'd probably be fine. But really, I like to make sure that everything that's coming out of Houdini is clean. So I'm going to redo it. So I'm going to just, let's just delete this. I'll go back over here into Houdini, and oftentimes I'll troubleshoot this until I get a very clean file. So I'll just throw down a clean node, which if I middle mouse click here, if I throw it on this clean node, sometimes this takes a little bit of trial and error, but I could do things like remove, by default it has remove NaN, select and remove under unused points, and remove degenerate primitives. This basic setup right here generally tends to get the job done, so we'll just see if that did anything. I'm going to save this to disk again, so it's going to overwrite the other file that we just created. And when I go back over to Cinema, I deleted this file out. Generally, I find that it works pretty well when I'm first getting things set up to delete the file out and re-import it. But later on, you can actually re-import files you don't necessarily have to re-import the file. You could actually just update the file and then reopen Cinema, and it will link to the correct file. It doesn't always update live in the object manager. I found if I've updated a Alembic file, it doesn't come in right away. So a lot of times what I'll do is I'll save, and then I will say revert to saved. So simply just saving and revert to saving causes Cinema to reopen the current version of the file that we're on, and then a lot of times that triggers it to grab the right Alembic file. So if I go over here and say merge again and open that up and click OK, we're still getting this extra spline that's in here, this RBD fracture. So I'm not 100% sure what is causing that. It looks like it's these two little primitives right there, which, oops, I was having a hard time. Looks like it's just this little tiny spline that somehow slipped its way through. So let me see if I can further figure out how to clean this up. If I middle mouse click here, I've got 27,000 points and 23,883 primitives. If I go to the clean, we now have 23,610. So it is deleting something here, but it's not getting everything. So I need to see if I can figure out a way to get it to delete those. Maybe what I'd try now is manifold only topology. I'm not sure if this is actually going to fix it, but I'll give that a shot and just hit save to disk. And I'll just try updating this the other way. So I'm going to actually say file save, and then I'm going to say file revert to saved. Are you sure you want to close? Yes. And then it will reopen the project and relink to this. And you can see that it still hasn't figured out how to get rid of these pieces that we don't need. Right now, not that big of an issue. I'm going to just move along from it for right now. Really, if I wanted to, what I could do is I could go over to Houdini and write some logic that said if there's any piece that has 2 or less points, then delete it. Do I really want to do that? I'm not sure. Let's see. So what I'll do right here before our clean is I'll throw down a measure sop. And if I throw this in here, it's set to measure area, which is fine. And if I go over to my geometry spreadsheet and look at my areas of my primitives and sort this by size, you can see that there's 2 primitives that have 0 area. And what I could do is actually, let's just delete this. Let's delete these 2 based off of the fact that they have 0 area. So I'm going to create a, let's see. Let me think about how best to do this. I'm going to use a delete node. So I'm going to throw down a delete like so. And I could delete by expression. And what I could say here is at area is less than some extremely small number like 0.00001. And if I hit enter there, now when I go and sort my areas, I do have certainly very, very small. In fact, this is actually getting too close for comfort. I think what I might do is put another couple zeros in there. Yeah, because we have some some faces that are way, way small into the -7s. Let me just make sure I'm not actually hosing. Yeah, we've even got some that are 10 to the -8. So I'm going to need to be very, very explicit about this. Very extreme with this limit. So I'm going to just put in, I've got 0.0000001. I'm going to put in 3 more zeros just so that we're that much closer to 0. So that we get all our areas to the -8 are still in there, but we've removed 2 primitives. So now if I go to my measure shop, middle mouse click, I've got 23,883. And now when I go down here and middle mouse click on this delete, I should have 23,881. So 23,883, let's go over here, middle mouse, 23,881. So I've effectively isolated those 2 stray primitives with 0 area and deleted them on my own. So with that being said, thanks for nothing clean. I'm deleting you, you're gone, and we're going to go and re-export this one more time, see if that fixes it. All these little tricks and things are just, you know, it seems like a lot of hoops that you have to jump through, but really there are things that you just eventually, over time, kind of get used to when you are working back and forth between Houdini and Cinema. Is just, it's about problem solving, really. That's what 3D is in general. It's you're generally faced with challenges and trying to solve them all the time. So I'm going to just hit File, revert to saved one more time. So yes, it looks like it's having an issue here. It doesn't know what to do. So what I'm going to do is I'm actually going to just delete this, import RBD out, file, merge, and I'm going to merge in the RGB fracture again and hit OK. You can see now that it's just one solid alembic, just one alembic file, which is what we were after. I didn't want to have any extra spline nonsense in there and whatnot. So you can see it's got our face selections. So all of our inside faces we could assign a unique material to. And it's got our outside faces, so we could assign a unique material to those as well. And we've got our, we've effectively brought in this part of our animation. So we also do have these vertex maps, and these are basically representing velocities in X, Y, and Z. So I'm going to just quickly fire off a redshift render. So I'm going to open up my redshift render view, and I'm going to just put a redshift tag on here. So I'm going to go to redshift tags, redshift object right here. I'm going to go into my render settings as well. Nope, not that one. Render settings. I'm going to go to redshift here and choose to enable motion blur. And we're going to just try and get these weight maps to give us some motion blur on our object. So if I go back here and I go to my redshift object tag and I go to the motion blur tab, we can see that there is this motion vector section right here. So I can turn that on, and then what I can do is just drag in my velocity tags, that weight in there like so. And then if I render this for pairing, Just going to add a light so I can see things a little bit better. I'm going to go up to my Redshift menu, lights, and create a point light in the scene. And I'll actually make that an area light. I'll just bring that up a little bit. Give it a rotation like so. It's actually massive, so let's just bring it over here like this. Up, and let's do 10 by 10 and bring the intensity up and just go back one frame. Should be back in view. Bring the intensity up a little bit higher. Maybe let's try 1,000. Maybe 500. And I'll just also turn on GI. And let's just get this area light in a little bit better position. Just go like that. I just want to be able to see a little bit better. Going back here. Okay, so I don't see any motion blur yet. I think that I have to also go out to my object tag, and on the motion blur setting, it is I'm going to override this to turn on motion blur, and it's using the global setting, but I want to choose transformation and deformation. And deformation steps, we'll use the global setting, that's good. And let's go back over to our Redshift settings, and where it's talking about under the basic tab, motion blur. I'm going to tick enable deformation blur, and I'm also going to stop this and click render again, and then I'll switch to object to bucket rendering. Not seeing it yet, so what I might do is let's mess with the scale. Just bring that up to 200. It looks like motion blur didn't necessarily want to show up until I actually hit the actual render button and not just the IPR button. So I'm just going to bring the scale back down. 200 is extreme, but that's more or less just because I was trying to get it to do something, making sure it wasn't too subtle so I could actually see what was going on. So I'm going to stop that, and I'm just going to hit the clapboard one more time. And you can see that that motion blur is still way too drastic. So let's just dial this back a little bit more. Let's go do that. And I'll bring the scale back to maybe 0.1. See how that goes. Hit the clapper again. And you can see there now our motion blur is occurring on our golf ball geometry. I'm getting that motion blur coming in from these motion vector weight maps that came over in the Alembic file. So that was an overview of how we can get geometry out of Houdini and into Cinema 4D as an Alembic file, as we did with our rigids here. And in the next section, what we're going to do is we're going to focus on getting smoke out of Houdini into Cinema 4D as a VDB. So stay tuned for that.